Good evening. Hope you guys can enjoy the session. Tonight's session is all about transformers. And then the second part of it will be lighting. So we'll do transformers till about 7, have a smoko, and then after the smoko, we shall then hit lighting. Now, lighting, guys, is not a thunder light. It's lights about like fluorescents and LEDs and all that lovely things. Now, we shall do that after the smoko break. But firstly, we're going to talk transformers. Now, you all know what's a transformer. Technically, it's two motors. It's a primary connected motor or a secondary connected motor. That's all it is. And the problem is, a motor doesn't turn. Sorry, try again. A transformer will not turn. A motor does. So that means there will be bearings and a rotating shaft in a motor, but in the transformers, it's just a coil. And the magnetic field of the one cuts through the other one, and a transformer can do one or two things. It can either up the voltage or down the voltage. It can up the current and down the current as well. Happy with that? Now, when you're going to build a transformer, you must use a core. Now, you get 3 types of cores: open core, closed core, and a shell core. They give you a picture and they ask you which one is which one. Can anybody tell me what's the first one in the left-hand side? Open core. So on that one, you got a coil and you got another coil on top of it. So that induction is called self-induction because it cuts through its own windings. The one on the right, sorry, in the middle, what do you guys think is that one? Closed or shell? Closed. Closed. Right. That one, there's normally a coil on the left-hand side, another coil on the right-hand side, and a magnetic field flux through the metal. Now that metal has laminated plates, and we call that mutual induction. Right, and the last one could be both, could be open, sorry, try again. The last one can be self-induction or mutual induction. Depends how you wound your windings. And what is that one? Have a guess. There's a shell core. Right, so guys, I'm going to say this again. In the exam, they can ask you either or all 3, or maybe not even one. Depends on the luck of the draw. How are you going to get questions? So you must know the cores. Is that clear to everybody? Now let's get to put some coils around it. Coils means windings. Now if I put windings around it, you'll see there is a typical transformer with some windings. And this windings has got a primary side and a secondary side. Tell me when you look at that. There's one set on the one side, one set on the other side. Is that a single phase or a 3-phase transformer? Single phase? Well done. Next question. Can you look at it? Left-hand side, primary side, secondary side, right-hand side. Do you all agree there is a primary voltage and a secondary voltage? There's a primary turns and a secondary turns. There's a primary current and a secondary current. Do you all know that all that forms a formula? Voltage primary, voltage secondary, turns primary, turns secondary, and current secondary over current primary. You know that the current is inverse proportional. So from that, you can see a formula. Now, when you look at that picture, can you see there are 2 coils separated from each other? The one magnetic field cuts through the other one. We call that mutual induction. Got it? So in the exam, they can ask you, when 2 windings are separated from each other, what is the type of current? Oh, sorry, inductance you can get inside the transformer. Is it self-induction or is it mutual induction? If they're on top of each other, it's self. The one cuts through the other one. It's self. Mutual means the one does not cut through the other one. That's the easiest way to remember it. You guys with me? Right. What else do I need to know from that? Is this. And the top picture. Can you all see there is a load, a primary side, and a secondary side? You all happy with that? Gentlemen and ladies on board, please make note, regardless how you look at this, there will be a voltage on the primary side. There will be a potential voltage in the secondary side till, yes, till you put a load on it. Once you put the load on it, then only the secondary current will flow. So when you put a transformer on, you got primary voltage, you got secondary voltage. Once you put the power on, you will get primary current. You guys got it? But if there's no load in the secondary side, there will not be a current in the secondary side. How's that sound? Now, I don't know if you guys can all see. I'll do this, and I'll do this, and I'll do this. This is my laptop calculator. Oh, sorry, try again. If you guys can see online. This side is my primary side. This side is my secondary side. We have plugged into my laptop. Now, a couple of questions I need to ask you. You all agree you could put a voltage on the primary side and you'll get a voltage on the secondary side. Happy with that? If you put a voltage on the primary side and there's nothing connected to the secondary side, there will be a primary current only, and it will cut through. And guess what happens when you switch this on at home? You start paying for electricity. Once you plug the secondary side into a load, then the primary current will go up and you start paying a little bit more. Now, who of you guys got cell phone chargers at home plugged in without a cell phone? Did you know that you're paying nothing? You're wasting money as we speak. About 20 to 30, maybe 40 cents a day. You're wasting money?
About those PowerPoints with the USB, isn't it?
Now, a PowerPoint with a USB in it, it is maybe microcurrent. But you are actually paying for that. But the USB is, we talk about microcurrents. This could be up to 1 amp. That is payable and costable. So let's go back to this transformer. You all agree, primary side, secondary side. If I put 230 volts in, there could be a 6 volt in the secondary side. Is this a step up or a step down transformer? 230 to 6 volts. Step down. Now, gentlemen, ladies on board, never, ever, ever we rate a transformer on its current. If I say step up, it means it steps the voltage up. If I step down, it steps the voltage down. Is that clear? So in the exam, the question will be as follows. A step down transformer is given. Is it the voltage or the current? What will you say? Voltage. Please, please, please don't stuff that up in the exam. Is that clear to everybody? So, 11,000 to 400 volt transformer, step up or step down? Step down? Step down? Good. Right, that transformer there, you see on the computer screen, the top one. If I take the globe out, there is a potential voltage. Let's say I put 230 volts in, I get 12 volts out. There is 12 volts. As soon as I connect the globe on it, current will flow. But if I take the globe out, there's no current. You all agree with that? Now, before I do further, you all agree there will be a primary voltage, a primary current, and a potential secondary voltage. Potential means before volt drop. As soon as I put that globe in, current flows. But what will now drop a little bit? The voltage. Secondary side. That's all drop. Right. Now, current flows through the secondary coil. And because of that, there's a back EMF through the metal, which works against the primary windings. And that will then slowly increase the primary current. That is the hardest theoretical transformer question you can get in the exam. So the exam question will be, if I connect a load on the transformer, what happens with the primary current? Does it increase or decrease? Look at my picture, the arrow on the left-hand side. It goes up. It increases. You guys happy with that? Happy? Well, whatever the load is, that will be the current. So it will go from 0 maybe to 2 amps. It depends on the resistance. So if I rewind quickly, no current. So yes, current will increase. It will go up. It will either, and as you switch the lights off, the current will go down, 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 down. Got it? Now, as soon as I switch the light on, yep, current will flow in the secondary side. But what you don't know is a back EMF through the coils, and that will create the primary current to go up a little bit. Not much, but it will go up. So instead of paying 5 cents an hour, you're going to pay 10 cents or 7 cents an hour. So when you go home tonight and your cell phone is warm, then you know that you paid 25 cents for the day for nothing. Pay me $100 a week, and I'll go to all your houses and I'll just unplug your transformers for you. Nobody wants to do it. So anyway, throw that money away. Guys, when I go to my micro oven, the LEDs is on. Is that right? I'll pay for that. Even if the transformer doesn't turn. You go to the stove, the clock's working, the lights are lighting, you pay for that. So that is, we call that wasted current. We all pay for, which we say, so little, I'm not caring about it. Is that right? But if you add up all the transformers and all the lights, which is working for no reason, we're wasting a lot of power in New Zealand, unfortunately. Anyway, that is theory. Are you all right with the theory of a transformer? I don't want to spend too much on this because that's about all what you need to know. So very important. Last time I'm going to ask this. What happens with the primary current of a transformer if you connect a load on it? Will it increase or decrease? Increase. It goes up. Happy with that? Shut. That's not hard now. Right. If you get a question and you say insert, press, press. There it is. Which one is number C? Shall. Well done. It shall be that shall. Right. You guys happy? Good. Anyone try that one? Everyone got that one? I'll just keep on admitting more people coming in late. Right, try this one. Right. What is that? Do you think that's a baby transformer or a massive transformer? But guys, that transformer is also mentioned as a power transformer. Now, if you have a look there, if you know where that is, anybody know where that is? In Auckland? If you go to Ellerslie, there's a Turner's just across the road.
By the motorway.
Yes. Well, not at the road. It's about half a kilo in.
Caught on fire once.
Yes, I think that was the areas where the fire was. Right, guys, is that classified as a power transformer or a little Mickey Mouse transformer? It's a power transformer. Right, guys, just a matter of interest. How do you keep that transformer cool? Well, right, look at my cursor. Can you see that tank over there? That is an oil reservoir. Can you see this fans here? So this transformer is oil and fan cooled. But, here comes the but. We need to know something a bit more. We'll talk about that shortly. So before I start with this calculation or this motor, you all agree that, let's try again, transformer. Do you all agree there's a primary current, secondary current, primary voltage, secondary voltage, primary turns, secondary turns. Now, because this is a three-phase transformer, there's a connection primary side and a connection secondary side. Have you ever heard about star or delta? Right, and the last thing we need to know is this transformer, even if it looks big, there's two methods of cooling, the outside and the inside of a transformer. And you must know that. And I'm going to show you how easy that is. Right, there is a baby transformer. Okay, one in a TV or a micro oven. Now, can you also see there's a primary current, secondary current, a primary voltage, a secondary voltage, a primary turns, secondary currents. Now, can you see that one's cooling method will be air only? Happy? Cool. Now, a transformer has got winding inside. Windings means coils. Now that coils is made out of copper. You all agree? Right. Now if you're going to look at this, you're going to say, but hang on, I've seen this. If you have an input, you have a mode transformer, you've got an output. Isn't it true that that's also called the efficiency of a transformer? Like a motor? Input power, output power, efficiency? Yes. Transformers can also be rated as an efficiency, but we hardly touch that in our syllabus because it's not even examinable. But what you need to know, what do we call the losses inside a transformer? Now, have you guys ever heard about copper losses? Isn't that the same what we get in motors? I mean, copper losses is I square R. Have you guys ever heard about iron losses? Okay, iron losses. Have you? Now, iron losses is due to the metal inside the transformer. So, let's look at copper first. Copper losses is because of the copper inside it. As you create length, there's more losses because there's more copper, which is more heat. Now, that copper losses is determined by P equals I square R. But that's more than enough what you need to know. But here comes the part which is always in the exams. What are the two types of iron losses you get? I gave you the answers. It's called eddy currents and hysteresis. Isn't that the same as what in motors? We did this already. You all know that eddy currents is reduced by using laminations, thin plates. To reduce the current in the plates, we make it thinner. If it's one big solid mass, it means there's going to be a lot of current. But these plates are insulated from each other. They're touching each other, but they're not conductive to each other. Right. Secondly, hysteresis is the same as a motor. Due to the change of magnetic field, AC all the time, the metal parts will have, let's call it, induction friction. North pole, south pole keep on changing all the time. And because it's keep on changing all the time, that's called hysteresis. And to reduce that, we use silicon steel. Now, guys, help me right. Isn't that the same as motors? Now, there's two which you can't get in motors. One, friction. Is there bearings inside a transformer? No. Is there something which turns? No. There's no windage. So that's it. That's the losses in the transformer. Iron losses, copper losses, due to the windings. What you must know, what are the types of iron losses you get? And that is eddy currents and hysteresis. How do you reduce it? By use lamination or use silicon steel? Will you get an exam? Yes. Is it hard? Well, if you know the one, you know the other one. If you know motors, you know transformers. Right. When you look at a transformer, you'll see that the transformer will have some form of acronym written on it. Can you see that the top one says ONAN? ONAN. Okay, we'll see that. The middle one says OFAF. I'm not swearing to you guys to OF, it means go home. I'm trying to give you the acronyms. Now, something you need to know, which is very important. The first two letters is the inside cooling method of a transformer. It's not inside, it's on top. No, inside. The second two letters is a cooling method on the outside of a transformer. So, firstly, the first two letters. The first letter can either be O or an A. O for oil, A for air. You guys happy? If I say O, what is it? Oil. Is it true that's oil pumping down through the windings? You guys with me? But now that oil, is it natural or is it forced? Forced means is there a pump circling it, or natural means it's just lying in the oil. You guys with me? Right. Then the second one it's exactly the same. It can be oil or air. And again, the outside of the transformer, it could be a fan connected to the winding or to the fins, and then there will be air flowing through it, and that air can be forced or natural. Now, very important, the first one. Can anybody tell me what does O stand for? Oil. Oil in the inside, and it's forced. In other words, it's oil pumping through the windings all the time. Okay? Let's try the second two. What is that? Air. So there's air in the outside. That means just air. But now let's find out. Is it blown by the wind or is it blowing by a machine? Natural. So that means just normal wind blowing. So wherever you sit, think about this. You're in the outside. You're sitting. It's air cooling us, correct? But is it natural? Yes, natural air. So we're all here, AN. Let's try the second one. What is O?
Oil.
Forced. Right, and the second one, air, forced. Does it make sense? So, the thing in the exam is, they're going to give you an acronym ONAN, or OFAF, or ONAF, or AN, try again, ONOF. They can give you any sequence, and they can ask you what does it stand for. One. Secondly, they can also ask you, what is the readings for the first two? Is it inside or outside? Remember, we always start inside. So if I say inside oil, it will be an O. Inside pumped will be an F, OF. Outside air, natural or forced. Guys, you will get a question like this in exam. And a lot of trainees told me they had the acronym and you had to say it to them, what's the acronym? Or they will say to you, this transformer is oiled outside, inside, and there's a fan. So it's O, F, oil, fan. Outside, air, fan. It will be A, F. You will get that in the exam. If you want to remember that, you're welcome. If you're going to practice it, great. If you don't want to worry about it, that's also all right. But I'm telling you now, it's a 1 mark you need to pass this exam. So O for oil, A for?
Yeah.
Right. N for? Natural. Natural means just normal air. Air or oil just standing there in the bath. The bath is just full of oil. There's no oil circling. And what does F represent? Forced or fanned. And forced just means there's something circulating it for you. You guys with me? Please, guys. This is really not too hard. Right. Look at this one. What is that one? Can anybody tell me how that transformer is cooled? Let's start inside the windings. Inside. Oil? Natural. Outside?
Yeah.
What?
Natural.
Air natural. Yeah. Can you see that transformer labels has got methods of cooling as well? So guys, do you agree that this transformer is in an oil bath and it just lies in the oil? And then it's got cooling pipes outside where the oil is lying in, and as the wind blows, the air is cooling it down. Cool? Now guys, that's what they do in the exam. They ask you, what does ONAN? They give you 4 answers. You have to choose the right answer. Oh my golly. I hope you guys can imagine this, how easy this 1 mark is. Right guys, I gave you 1 mark. There's 59 to go. How's that sound? Now, I don't like to put people on the spot, but I guarantee you, if someone already sat this exam, I would love to ask you, was a question like that asked? A majority of the people said, oh, can't remember. Because there's a lot of questions, yes. But if you see that next time, will you know what's it about? So I'll give you a hint. In that transformer, the acronym on the nameplate says ONAN. What does it represent? And then you just have to go and read which one says that normal. Guys, if I say natural, it means N. If I say forced, it's F. Easy. Oil with a O. Air with the A. Happy? Cool. How's that transformer cooled inside?
Oil.
You all see the oil tank, eh? Now, if you look nicely, I know you can't see, but can you see that on the sides there's fins? There's no fans. So I will say oil forced, air natural. Because if a pump is at the top, it's gravity feed, but the oil most probably will circulate all the time up and down to ensure that the oil cool down, and it will go through the fins as well to keep it cool. Happy with that?
What would a natural oil setup look like?
Have you ever seen a welding machine? Just oil inside?
Yep.
That's natural. It just lies on an oil bath.
So they won't have the tanks.
Most probably no tanks. Yep. Now, guys, here comes a question which I don't think they'll ask this, but a law states if you're on a ship, you know what's a ship? A big boat, all right? The Team New Zealand won the second race. I know they won the first one. Nobody? Okay, cool. Right, let's try this again. A transformer which is in a ship must be the dry type. No oil. It's just air cooled. Why? I'll give you a hint. When there's a lot of movement, the ship goes left, right, left, right. Is it true that the oil will have a lot of movement in it? And it can start damaging the inside. Wear and tear. So there we are. Well done. So that's why they use dry type transformers on a ship. Right. The transformer in your micro oven, the transformer in your car, the transformer in the fridge. Is it the dry type or the wet type? Must be dry, because I don't see a oil bath inside my micro oven. Don't shake it, there's oil in it. No, man. All right? Okay, when you look at my transformer there, what do you think is the oil reservoir at the top? I'll give you one hint. Let's say it's a natural. There's no... Have you guys ever heard about gravity feed? Gravity feed? Yeah. But guys, the oil tanker at the top. As the oil gets hot, what happens with the metal? It expands. Now, we don't want that metal to crack. So what we do, we put a pressure relief valve at the top of the oil tanker. And as the pressure builds up, the pressure will relieve. Now, today's transformers, I spoke to some clever people who works on them, said to me that a lot of them is computerized. There's microchips inside the tank. And as the pressure builds up, with that topic you guys would have learned in level 4 called process control, pressure switches will activate the pressure switch, and it will open or close the valve. Now guys, if you go to your car, can I confirm that your radiator has got a pressure switch as well? But it works with a spring. Is that right? So as your engine gets hot, it pushes the spring up and it will come out. Don't wedge that close, because otherwise problems. Right. Oil moves through a transformer. And if the oil gets contaminated by air inside that, there's a special relay called the Buchel relay or the Buchholz relay. This Buchholz relay will detect any types of air bubbles inside oil. So think about this. You all agree that bubbles will always rise up. Right. So if the oil flows through that valve or that big relay, the oil will go up and activate micro switches. Normally the micro switches inside there in the olden days used to be mercury switches. Now as the bubbles go through it, it will bump the switches up, and when it starts bumping it, the micro switches will activate an alarm or even switch the transformer off. Right. Don't do this at home. I'll repeat, don't do this at home at all. But if you take phase and neutral and you put it in water, is it true that you can boil the water?
Yep.
Right. Don't do this at home. But anyway, if you take phase and neutral and you short it out inside water, what does it make? Arc? Yes. But what does it give off?
Heat.
Yes, but also bubbles. Now that bubble, so any transformer inside if the windings start scratching to the earth or scratching against each other, and this arcing, that bubbles will be detected inside the Buchholz relay. And the Buchholz relay will either switch alarm off or even switch a transformer off. It depends about the severity of that fault inside it. So, what's the purpose of the Buchholz relay? Is it there for overload current? Is it for short circuit current? Is it there to detect any type of moisture or maybe bubbles, not moisture, bubbles inside the oil? That's the one. You guys with me? And they asked that in the exam. So, this Buchholz relay, you can imagine the oil flows through it. And as the oil flows, air will go up and it will activate the switch inside. When I was an apprentice, every Friday we had a transformer. We had to go and service this Buchholz relays. Once every 6 months we had to do one. And you can imagine if I do one every Friday, there's quite a bit of transformers we had to service. And also you find that there were switches where we switch it off, close it, for oil not to flow through. Once we close it, we drain it, and then we do it. But that transformer will be switched off because there's always standby transformers at hospitals or places like that. Anyway, that was good times in those days. Right, now we see a transformer nameplate. You will all be able to eye it. Can you all see it? Right, can you all see that this transformer has got tappings? What's the purpose of a tapping? A, is it there to let the transformer looks nicely? Or do you think it's there that you can change the voltage? Is it there? So if it's 11,000 volts, I can make it 10,000 volts or 11,900. I can set it up or down. I know you guys can't see this yet, but I'm going to do this one again later. Can you see this is an 11,000 volt transformer, primary side? Secondary side, 415 volts. Primary current, 10.6. Secondary current, 278. Now, guys, have you guys ever heard about a transformer formula which says NP, NS, VP, VS? I took the current out. Now, if I drop the voltage in the primary side, sorry, try again. I drop the turns in the primary side. I make it less turns. That means less voltage. Is that right? Look what happens with a secondary voltage. It goes up. Now, one of the sneaky questions is as follows. If I switch something, is it cheaper and easier to switch 10.6 amps or 78 amps? Which one is going to give you the biggest arc and spark? 10. So guys, you all agree that in the primary side, the current is smaller. So technically, it's smaller contacts. All right? Secondly, if you drop the turns, it's easier because then the secondary voltage will go up. But to add turns, it's very costly because where you're going to add more turns on the transformer. So the moral of the story is we put the tappings in the primary side so we can keep on dropping it to increase the secondary voltage because voltage and turns are proportional, but primary and secondary is inverse proportional. So if I drop the turns, I up the voltage. So here comes the story. Where will I put the tappings? In the primary side or secondary side of a high voltage transformer? Primary side. Got it? They asked that in exam. Cool. If I give you a three-phase transformer, how do we connect the three-phase transformer up? Have you heard about star, star, delta, 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 star, star, delta? If you look at that one, what do you guys think is that one? Anyone online? Can you have a chap? Yes, Graham, you are right. To change the voltage from a reference point. That's right, because 11,000 is the standard voltage coming in. Cool. Right, guys, I want to show you with my mouse, my moose. Can you see there's no coils shorted out with each other? The one coil goes to another coil. The one coil goes to another coil. What is that? Delta delta or star star? Yes, delta delta. The other one I'm going to bring up is that one. What do you guys think is that one? I'm going to give you a hint over here. Can you see the one end and the other end and the other end is all shorted out? What do we call that one? Star star? Right. Primary, left to right. Or if it was other way around, it was flat, it will be primary at the top, secondary at the bottom. Now guys, in the exam, I was told by trainees that the neutral wire, which was here, was taken out. And normally what you do with the secondary side, the star side, you earth it as well. But in the pictures, in the aspect exam, it comes up like this. So I took it out to give you an idea that star don't always have to show in neutral and earth. All right? Now, give me a hint. What is this one? Left to right. Left. Secondary side. Star delta. Now, can you see with this one, I just left the neutral and earth in to show you how we normally do it? Right. And what do you guys think is this one? Is it star star, delta delta, delta star, or star delta? Left to the right. Left to right. There's a star point this side, so it's delta, star. You guys with me? Gentlemen, ladies, this is a definite question in the exam as well. And I bet you those who have sat the exam before would have seen this question in exam and you had no clue what to do when you saw it. Will you have a clue now? Please, double check. Those who got my books, it's questions out of the book, straight out. Go and check it out. It's not hard. Right. Why did that happen? Hey. Sorry, guys. There we are, better. Cool? Happy with that one? Right. Have you guys ever heard about the auto transformer? Can you see an auto transformer has got a common neutral? Got it? I'm going to talk to myself because this is critical for everyone. An auto transformer share a coil. It's a common neutral. The construction is simpler because there's only one coil with a tapping. Number two, there's way less material used. We have one core. We don't have two coils and two cores. It's cheaper, it's smaller. And what it means is, by the word regulation, if you put voltage in, your voltage drop is way less than a normal transformer. The disadvantage is what you must know for this exam. Now, if I see this transformer and it's 230 volts, that's like 12 volt. Does anyone know or heard about AS/NZS 3000? Did you know that in chapter number 7, there's a topic called auto transformers? And in that exam, they asked the question, the secondary side of our auto transformer load must always be rated at primary voltage. That means if this coil, say there is an A, if that breaks, that voltage becomes 230 volts. So can you see it's a safety catchment? Now, have you guys ever seen, it's like a big rheostat. You can turn it and change the voltage. You physically got a button and you can turn it. That's a rheostat. That's an auto transformer. So you can have 12 volt, 24, 100, 200, 230. So the load of an auto transformer must always be rated at the voltage of the primary side. I'd love to ask that out of AS/NZS 3000. Right, so let's look at the first hazard, A. If you go and boop, you break that winding. See there where A is flickering? Right, so Before I do that, I just want to share with you. This is 230 volts, that's 24 volts. That current flows that way, and this one flows this way. Can you see that two currents cancel each other out somewhere? Right? Some of the good things this transformer does. If there's 24 volts, do you agree that the remainers is that side? So from there to there, I don't know, but I know from here to here is 24 volts. But from here to there is 230 volts. So from this side to that side is about what? 190 volts somewhere. Cool. Now, if you break A, what is the hazard here? Can anybody tell me? That voltage will rise to 230 volts. Can you all see that? It's a hazard. So in the exam, I believe they say the auto transformer is given. The winding which is common, see there's a common winding there, it breaks. What happens with the primary voltage? Secondary voltage. It goes up. Okay? So that's one of the hazards of an auto transformer. Are you okay with that one? There's only about 3 hazards. That's all. But 2 easy ones. The third one is, we'll see, because it will cause by stupidity. Now, if it says P and S, what does P stand for? Primary side. What does S stand for? Will you put your secondary side 230 volts on it? That's stupidity. So that's one of the hazards we can get. Now, if you look at this transformer, is it step up or step down? Step down. Cool. Right, let's look at the second hazard. If the neutral of the transformer is open at B, where's B? There. If you break that neutral. Got it? What is the hazard? Guys, see that voltage there? It goes to 0 volts. But the problem is, what's the potential voltage between that P and the earth? Still 230 volts. Right? So very important. There's still a potential hazard of 230 volts on that transformer. Right? So that is a very hard one to understand. If you break the neutral or you break the coil, it's now simple. Everything becomes supply voltage. How's that sound? Cool? Right. And the last hazard, obviously, this can result to a fire. This poor 12-volt motor is going to squeak like a little oink oink. And it's going from 230 maybe to, or sorry, from 12 volt to 230 volts. But the problem is, if that breaks, there's a potential hazard on neutral, which is 230. And if you touch it, bacon. Right. And the last one is this. If you swap phase, see there, phase to neutral, and this neutral to phase, will you do that? Is it possible if you don't read P and N? If you don't, can you see that in this side, the earth becomes live now? Right, guys? That becomes hot, in other words. So my question is, if a fault occurs on an auto transformer, does it become hazardous? Yes or no? Yes or no? Yes. So the moral of the story is, an auto transformer is not a safety transformer. You cannot use that to give electricity to kids, to a 12-volt toy. Got it? Now, guys, this is still being used in the industry, but majority of them, I will say, we use it in labs at polys. I might see it in a lab where you want to change the voltage a little bit, but that's old school. Today, in motors, we use star delta and prime resistance and all that lovely motors. But in the olden days, this rheostat used to be an auto transformer, and we could have used it. So you all agree that that will become live to 30 volts. So guys, moral of the story is, if you've got an auto transformer, what is the possibility that everything can become 230 volts if something goes wrong?
Very high.
Very high.
Where are auto transformers used?
I would say in laboratories, or where you do experiments and that type of things. I don't see any more auto transformers out in industry anymore. It used to be in the 80s and 90s, but they're phasing out because there's better technology there now. I could recall when I was a youngster, I used to have a train set. And my dad made me a box, and I plugged it in, and I connected to the tracks, and I could turn it, and my train will go fast or slow, because I used to run out of batteries like a sick person through tissues. And I used to do that. And then it was such nice fun to take the two wires and short them out all the time. And then, yeah, dead when the fuse went. But I was bloody lucky, because one day I looked inside, it was a little auto transformer. And if I think back today, I could have been bacon. You see, other consequences could have been, but the angels was on my side. So guys, you guys okay with that? All right. So to recap, our auto transformer is also a step-down transformer, but it's got hazards. And if the primary coil, the common coil, the neutrals, or everything swapped around, there could be a potential hazard of 230 volts to all metal parts. You guys okay with that one? All right. Right. Now we're going to talk about a current, or let's call it instrument transformer. Now, why do we use instrument transformers? Now, I'm going to give you guys another hint. You will get a question of this in the exam as well. Maybe one or two. This acronym, CTVTs, have you heard about them? What does a CT stand for? Current transformer. And anybody, what does a VT stand for? Voltage transformer. Right. So if you look at that, can you all see there where number one is flickering? It's your CT. Right. What is normally connected to a CT? An ammeter or a voltmeter? An ammeter. Right. Look where's number three. There's number three. Can you all see it's a VT? You know what VT stands for? Voltage transformer. Now, if you know what's number three, what's the type of meter normally used for a VT? A voltmeter. Right, guys, I'm going to give you a very difficult question. If I put 7 acronyms down, I call them 1, 2, 3, 4, 5, 6, 7, as what I did now, or 6, and I tell you what they all are. Will you be able to tell me that A is a CT, B is a VT, C, D is an ammeter? They asked this one in the exam. And you know what's the sad part? People get it wrong. Now, we just talked about a VT and a voltmeter. But a voltmeter and ammeter combined becomes a wattmeter. Now, and the last thing I'd like to share is your load, number 6, must be there. Otherwise, there won't be a current. You all see with that? Now, gentlemen, ladies, in the exam, they ask you questions like that. Where is the CT? Or what does CT stand for? Or what is the symbol for a CT? What is a VT? Or what goes with a VT? Are you guys okay with that? So what I'm going to do now, I'm going to break it up in smaller little clusters. I'm going to talk about the CT only, then the VT only. All right? Now, let's look at this one first. The acronym CT stands for current transformer. The acronym VT stands for voltage transformer, but you can also get it as a PT, a potential transformer. You guys happy? Right. Now, voltage transformers. If I give you the real McCoy, but then I'm going to give you some symbols, how they can look like. Okay, the right-hand side one was a bit shaky. But anyway, if you have a look, can you see that the VT is actually a little step-down transformer? Now, here comes the million-dollar question. What is the nominal highest voltage we're allowed to measure on the secondary side of a VT? Is it 230 volts, 110 volts, or 12 volts? 110. So that means if I've got a VT, you will never ever measure more than 110 volts on that side. But I still haven't told you why we use a VT. I'm going to do that very shortly. But before I do that, can you all see there's 2 types of VT symbols? The one over here with 2 fuses and one with 1 fuse. If you earth one side, you only have 1 fuse. If you don't earth it, you have to have 2 fuses. No law says which one to use. There's no wrong or right. The choice is the manufacturer. So if you go to this box, this top two is your 11,000 volts. What's the maximum I'll measure here? 110. Now, if there's one fuse, the other side is earth. If there's two fuses, it looks like that. Does it make sense? Right. Yeah, here comes the fun part. Can you all see my VT with the big little areas, and I put 11,000 volts there? Can you all see that? How much volts will you measure on the voltage meter? How much will it show? Will it also show 11,000 volts? Look, it says on the meter, kilovolts, 5, 6, 7, 8, 11, 11,000 volts. Can you all see? 110 volts will be here, but your meter will show 11,000 volts. Now, guys, the point is, your VT, the measuring part, is not 11,000 volts. It represents 11,000 volts. Does it make sense? So, what is the maximum voltage which can go to that voltmeter? 110 volts. You must know that. And again, as a giveaway, the majority of the questions on transformers is all these little things I put together. The big transformers, you might get one or two questions from it. So if your ability on transformers calculations is a bit hard, or rather say when it comes to transformers, learn the theory. You might got one or two questions on calculations which you can say, hey, see what I try to come down to? I want to give you that satisfaction to say there's not always a lot of transformer calculations.
Can you pass the whole exam without doing any calculation?
I would say yes.
That's good.
But then you better get all the other questions right.
Yeah.
Right, but I won't say all of them because there might be only about 20% calculations. So you can still get 80%. I'll tell you a story. I did a subject. Look, I'm not a mechanical person. I did a level 8 mechanical paper once. And I said to myself, I'm going to do this. It's all about when a car goes around a corner, what's the traction on any small rubber on a tire. You know some tires that got like 5 little grits on the tire? You have to work out the traction and the forces on every one. But this exam paper, 60% is theory, 40% is calculations. And I said to myself, this is a lot of calculations. I'm going to learn the theory. I won't even touch a calculation because there's like 20 formulas you have to know to do one little calculation with 2 marks. And I just said, oh, bugger this. So I just learned the theory. And guess how much percent did I get? 60. So I got all my theory right. I didn't touch a practical. And I only had 50 to pass, so it wasn't too bad. Now, don't leave the calculations alone. There are easy ones. Happy with that answer? Moral is, this is not a calculation. This is just to know. Now, if I do that, you all see that's a selector switch. The selector switch will determine if you measure the red and white, red and blue, or white or blue. Happy? Right. Sometimes that selector switch also say red and neutral, white and neutral, blue and neutral. Now, what do you guys think will be the red and neutral voltage if I measure 11,000 volts there? Take your calculator and say 11,000 divided by √3. Remember, line to phase voltage. And your answer will be, let me think, 6,000. About 6,350, correct. So that's good. Well done, Graham. You're writing good answers, mate. So the point I'd like to share with that one. Are you all okay? So if I go now and say, let me just see if I can blank this one out. Oh, bugger. What did that happen now? I apologize for that, guys. There. I'm going to ask again this question. What is the maximum voltage you will measure on the secondary side of a VTA? What's the maximum voltage here? 110. Please remember that. Secondly, there's 2 types of transformers. One with fuse or two with fuse? Right. If I got 110 volts here, and it's physically go to 11,000 volts, it's not really 11,000 volts. An instrument transformer is used to step down so that we can measure high voltages safely. Okay? Okay? Right. Let's look at the CT. The CT does exactly the same. A CT's purpose is to measure high currents safely. Now guys, you all have clamp meters. This is actually a clamp meter, or what it is. But this clamp meter we can't open. It's a solid one which is always in a bus bar. Now a CT has got some risks. We have to know the risks, and they're actually simple. So guys, CTs are rated either 1 amp or 5 amp. Now this little thing which goes on off in the right hand side corner, it's the symbol of a CT, and you will get that in your exam as well. And what they do, they just put it up and say, what does it represent? They're right there. It's a transformer. It's a piece of wire with 3 strings hanging on it. Or is it a CT, a current transformer? Can you see the current transformer? Now, don't know why they do that, but that is the symbol for it. Right. Now, a CT secondary side, let me show you, is I rated. What is this one rated at? See there? How many amps? No, the top one, that's VA. Can you see 5 amp? Secondary current, 5 amps. Sorry. So a CT is either rated 1 amp or 5 amp. But here comes another thing. Are they going to catch you? And I want to make this so clear that everybody hears it well. The normal secondary current of a CT is 5 amps. That is the normal one. But you also get it in 1 amp. So the standard one you normally buy is 5 amp, but you can get 1 amp ones as well. So if they tell you there's a 1 amp one or a 5 amp one, and you have to choose one, which one will you choose? In the exam, you're only allowed to choose one answer. What is the normal secondary current? 5 amps. Is that clear to everybody? Don't stuff that one up, please. But yes, if they ask you, CTs comes in 1 and 5, or 2 and 5, or 3 and 10, what is the answer? 1 and 5 amps. Cool? You happy with that? Right. I'm going to... Cool?
What's that? What CT is 5 amp
And some is 1 amp.
no, the after 5 amp
And also, I was supposed to say also the most common, but sorry, typing error. Whoever wrote this is a monkey. Right. So guys, you all agree. And by the way, all this is in the books. The pictures is the same. Now my question is, what is the maximum voltage on a VT? 110 volts. What is the most common secondary current of a CT? But you can also get it in? Fantastic. Right. I'm going to do a couple of things, and then I'm going to talk about other things as well. But firstly, can you all agree that this is a 5 amp one? Right? Cool. Look at this one. This CT is connected to a bus bar. Is it a 500 is to 1? Is it a 500 to 5? A 300 to 1? A 300 to 5? A 200 is to 1? Or a 200 is to 5? Right, guys? What I want to say, can you see the current coming in is 200 amps? So which one are you going to choose? 200. Now, let's go and zoom in here. What's written on it? So which one are you going to choose? Right, so if I got a high voltage system and I know there's 500 amps, guys, I got the choice to choose that one of the two. Now look what's going to happen. If 200 amps flows in the bus bar, the magnetic field cut through here. What is the maximum amps which will flow in the wine and in this wires? Look there. 5 amps. 5 in, 5 out. Got it? But what will the amp meter say? 200 amps.
Why is that?
Because all what it is, that this amp meter, it's actually 5 amps flowing in. So what they did, technically, it's 5 amps showing. So all they did, they just repainted and renumbered the nameplate. So that when it goes to 5 amp, it actually sees 200 amps.
How come you not done that?
Because you can't take a clamp meter, go to that bus bar and try to put it around it. So it's a measurement type of way to measure current safely without going to the bus bars and measure it. But you normally get this in the secondary side of a transformer, in a transformer house or in a factory. You won't get it in houses and stuff. Now, if you go home and you take your clamp meter, you put it around the phase wire, that's houses. But we talk this as more commercial, industrial environments.
So how come they would rather show you 200 instead of just tell you the actual value of 5?
Because we want to know how many amps flows in the bus bar. We don't. This meter, CT, is only there to transfer the ratio to the ammeter to tell you what amps is in the bus bar. Happy? Right, guys. Question: if I drop this voltage from 200 to 100 volts, amps, what's going to happen with this amps? What's going to happen here? 90 amps. You see that? So then, mommy switch on the lights, clink, 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 with that switch, and that will go up or down. Does it make sense? So that's what the CT do. But here comes a little couple issues. This coil, there's a magnetic field cutting through it. If you switch the ammeter off, something you must do with the CT, otherwise you're going to get smoke. And we'll talk about that now. And that you must know as well. Right, that's good. Discharge and short it out. Now look at this one. 201. Which one are you going to choose? 201. But guys, if you choose a 500 one, it's not true that if 500 is here, the needle will only go to 200 anyway. So it won't go all the way to 500. It all depends which is the ratio you choose. So if I say 1 amp, there will be 1 amp both sides. And then what will this show? Also 200. But this is not a most common one, but you get the 5 amp one, which is most commonly used. Now, what size wire must this 2 little wires be? 10 mil, 25 mil, or 1.5? I'll give you a hint. Look, it's only 1 amp. So that little 2 wires running here, we normally make it double insulated wires. Double insulated, and what I've always done it, I use 2.5. That's all I did because it's easier. And you know, you get appliance wire and you get conduit wire. I normally use appliance wire. It's just more flexible and soft, that's all. But again, talk to your boss, see what he wants to put in if they use it. Right, the sad part is, out of 75 people in this room together, I would say there will be a handful of people who ever touched it or saw it. But unfortunately, you must know this for the exam. Right, so again, if I drop the current to half amp, so it was 200 to 100 amps, that will drop and the needle will go down to 100 amps. Good to know. Right, an amp meter, you can select red amps, white amps, or blue amps and switch off. But I'm going to ask you the question. When the ammeter says off, what happens with that 2 terminals? What must you do? A, leave it open, or B, short them out? Always short them out. Now guys, when I was an apprentice, I saw it firsthand. A trainee went and he disconnected the 2 wires here, replaced the ammeter. By the time you connect it up, this thing already melted. So what you have to do, what we normally do, we undo this one, but before we do it, I put a crocodile clip there and there, short the 2 terminals out. You can't break it because the internal resistance of an ammeter is like 0 ohms anyway. So if you have a short in here or the short in there, it's exactly the same. Right, so let's look at the current transformer when it's left open. When the transformer is left open, 2 things will happen. One, the CT, the windings, will become so big and the windings will get so excited that it will start melting and overheat. But that's one. The second one, which is a hazard. When you touch that two metal pieces, you might lose your two fingers because of the high voltage, which is over that two terminals. So you're going to get a shock because of that voltage, or the CT will burn out. So what must you do to prevent that? A, leave it open, or short them out when you disconnect an ammeter. It's just hard, guys. Not too hard. So you have a CT, you have a VT. Let's recap. A CT. What does it stand for? Current transformer. What's a VT? Voltage transformer. Well done, Graham. You're putting good answers there. A CT, 1 amp or 5 amp. What's the most common amps? 5. But can I use 1? Yes. A VT, what is the maximum voltage you're allowed on it? 110. And the last question is, why do you need to short the terminals out on a CT when you replace an ammeter? A, to make it smile, make it work normally, or to prevent it to burn out, or to get a shock. Then you get a smile, eh? Right. Are you okay with that, guys? Happy? So, gentlemen, ladies on board, everything I've said so far, from tonight when we started, has been asked, but not necessarily all in one exam. 2 here, 3 there, 5 there, 6 there, 2 there, 1 there. But everything I've done so far, I bet you, is it hard? Quickly, what are the 4 types of connections of a transformer, 3-phase? Star, star, delta, 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 star, star, delta. Yeah. Let's go back further. There are 3 types of cores. Open core, closed core, and shell core. Yes. Let's look. A transformer's got a primary side and a secondary side. When I connect a load on the secondary side, what happens with the primary current? Fucking hell. Well done. Great stuff. Right. Now, this question, again, what is 1? CT, VT, ammeter, voltmeter. CT. What is number 2? Ammeter. Are you sure? Yep. Lovely. What is number 3? Well, that's not a very nice sketch. That's a ratio, 1 to 5. You guys happy? 1 to 5. Right, let's go to number 4. VT. Happy? 5. What type of meter is 5? Voltmeter. Right, 6. What's the voltage? Max? 110. What is 7? What type of meter? Volt amps? What? And what is number 8? Load. Gentlemen, ladies on board, very commonly asked question in the exam. I don't recall, but there's another question I lately put up. I did do it. I thought I didn't do it yet. Now, guys, it was hard to get this question from a trainee. It was very hard. Till I Googled, and I Googled, and I Googled, and I went back to him, and he said, Marius, I had that in the exam. 2 marks. So, when you look at it, in the left-hand side is your high voltage isolator. Now, what do we normally measure high voltage? Amps or current? I've just said high voltage. That is where your VT is. Your VT is normally on your primary side. What do you guys think is in the middle? A transformer. High voltage to low voltage. Now, what do you guys think is number 4? What type of instrument is number 4? CT, because the secondary side normally got the high current. And what type of isolator is that? Light. Low tension isolator. Or light, yeah. So, right. So, gentlemen online, ladies online, and gentlemen over here, when you see that question, you go, yes, 2 marks. Just remember, left to right. High voltage. Maybe in the exam, they will give you the middle part, which says high voltage, low voltage, or, transformer. Then you know, high voltage isolator has got a high voltage. The secondary side has got a high current. Is that clear to everyone? Check this. This is a very, very popular question in your exam. It pops up now quite a bit. The guy's getting it. Please don't screw this one up. Okay? Have it? Oh. How was that first part? Easy? Not right. Right. I'm just going to introduce you to a bit of transformers, calculations, and then we're going to do that next week, but more thoroughly. All right? Cool. Right, guys. Have you guys ever heard about single phase and three phase? What's the difference between single phase and three phase? Single phase is how many volts? Three phases? 400. Now, guys, the reason I wrote this question is once upon a time someone said it, and the guy said, I had this and this in the question. So it's very hard to find out from trainees whether they actually had an exam. So I created my question, and I thought, let's put it there as a discussion point. Can you all see that it's a 230 volt transformer? The ratio is 19:1. And the transformer has got a VA of 25 VA. So let's draw it. See if you guys agree with my picture. I give you a 230 volt, ratio 19:1. The primary turns is 2000, and it's got a 25 VA transformer. Now, what does VA stand for? Volt amps. What does the acronym use? P or S? P is wattage, which is PV cos theta. S is VI. So which one is that? 25 VA, S. Now, if you go to your nameplate, there's formulas. We'll talk about that. Now, what they ask, what is the primary current of this transformer? And you guys will say, what the hell? Now, guys, there's only two formulas you will use in this calculation. In transformer three phase or in single phase. There's only two formulas. Now, the first one is there, a ratio. It says V1, V2, N1, N2, I2, I1. But you guys will say, Marius, your red square moved up. I said, no. Look at the formula in the top one. What does it say? S equals V times I. There's your two formulas for transformer single phase. Three phase is just a root 3 added. That's all. Now, if you understand that two formulas, you can do all transformer calculations. So, if you see N1, N2, V1, V2, I2, I1, don't say, oh, it's supposed to say P and S. No, one can represent the primary side, two can represent the secondary side. Does that make sense to you all? Right, so it depends how you want to learn to what to do it. Now, guys, if I look at this one, if you want to use the ratio one, you must always have something in the secondary side as well. If I look at this, can you see there's bugger all given here? There's no voltage, there's no current, but there's a ratio of 1. See that? That is N1, N2. That is V1. Got it? Now, because I don't have a lot here, what formula is left? The S formula. Can I use that formula? Right? I don't have the currents either side. I cannot use that formula.
So S is the VA.
The S is your VA. Now, guys, here comes most probably the hardest part. Have you guys ever heard about this swearing word? Transpositioning. Transpose. Because everybody hates that. People don't like swearing. Have you guys ever seen what I just did there? Isn't that the transpose of the formula? Right, guys? If you say PVI, look, yeah, I'm going to teach you something easy. If you say PVI, put your thumb on P, VI. If you go to I is P over V. Just replace P with S. So option. So there's your formula. Without learning it, put your thumb on I, and it's P over V. Or S, represent S, is V times I. So either that one or that one. But also this one, V is P over I. Now, look, I don't want to teach you how to learn it, but I just try to show you. You can imagine the P becomes S. The only difference is a P technically adds cos theta, but in single phase like here, there's no cos theta. So you can put your thumb on and say S is actually the P and the P is the S. Now, look at this. Can anybody tell me what is S? 25 VA. How many volts is on the primary side? Right, there we are. And now look how small this is. 0.11. So how many amps is in the primary side? 0.11. Is that done?
So does the secondary side have the 5?
Also, we get to that now. Well done. So, when you see a transformer at your level, level 4, you will learn that the VA in the primary side is the same as the VA in the secondary side. Happy with that? When you're going to do your level 5, 6, 7, and 8, and you want to go do a BE degree and all that, you're going to learn that your secondary side is normally a little bit higher to compensate losses. But we don't have to worry about that now. Or what you need to know, that the S in the primary side is the same as the S in the secondary side. Now, here comes another question. If the voltage is 230, is that a step up or step down transformer? So do you all agree that that voltage will be 19 times less that side? Do you all agree that the current will be 19 times more? That's it. That's transformers. But to do more to less and less to more, we use that formula. But if you don't want to use it, or what you're going to say is 230 divided by 19, you will know what that voltage is. Or 0.11 times 19, you know what the current that side is. But it's actually, all what I just said is I took this formula and I transposed it. That's all I did. So let's try this again. You all know where I got this S formula from. Your VA, volt amps, is volts times amps. When you look at this formula, guys, you either look primary side only or secondary side only. You can't look at both at the same time. Then you're going to create a bit of havoc for yourself.
Do you think we'll be using the other formulas for S?
Normally what they do, they just ask to calculate S if volts and amps is given, or if they give you S and I, you can work out V, or they give you S and V, you can work out I.
Or would you be using that square root?
That is, if you come from the formula, it's another formula way to get from that. But if you look at this, this is S equals VI. Now, where did this come from? P equals I squared R. It's a bit of an Ohm's law. Have you ever had equals that P equals, no, try again. Voltage equals I times R. It's using that in another format. But no, you will not use that in transformers.
So we just need to worry about S equals VI.
Yes. Just names it so no, sorry. Right, that's right. So, moral of the story is, do you all agree that this transformer has got a voltage and it's got a current in the primary side? And the current will goes up and the voltage will go down because it's a step down transformer. You all agree with that? Right. Extra 2 questions. And those are the only 2 extra questions I must probably throw to you. What is the secondary voltage? Right, guys, if I give you 230, did someone say it is 19 times less? Have they? No, just name some name. What is 230 divided by 19? Just type that in your calculators. 12.1. You all agree the ratio is 19:1? Now, the voltage on the secondary side, we want to know what that is. You already know what the answer is. Now I'm going to show you how we actually do it on paper. But one of the good things in the exam, you don't need to show calculation. They just want to know the answer. Name, surname. Right. If I say to you on that formula sheet, there is a ratio. Can you see the ratio? Can you also see the ratio? No, we don't want to work at the current. We want to work at the voltage. So you have to do something with the voltage. You're going to say 230 divided by 19. Will you get that? But I want to show you how to get it. Where did it come from? Right. So if I do this, see that formula there? I'm only going to use two. I'm going to use voltage and what else? Turns. I'm not going to worry about current because the question state, calculate what? Look there. That part which goes red now. Voltage. Voltage, and I don't have all the currents. Don't use the current one. So there we are. You all agree with VS, VP, NS, NP. Doesn't matter which one I put at the top. Does it matter? Does it matter if I put primary at the top or secondary at the top? The answer is also no. Now I'm going to teach you something very interesting. My maths is not good. So what I did, I put my unknown one at the top. Can you see that? I'm going to go back now. What do they ask? Can you see that I put my unknown one at the top? So what am I going to do with the VP to get rid of it? It's true that that's going to go to the top. So if I times with VP, I times with VP. And that's where I get my formula from. I take that up. So now I don't have to twist it around and mangle it up. So I always put my unknown one at the top. Now let's put values in. Does anybody know what's my primary voltage? What is my turns? Primary, secondary side. What is my primary turns? Right. There we are. 12 volt. So the moral of the story is, you didn't even have to do it. All you need to do is take your voltage, divided by 19, there's the answer. Happy? Can you see where I get that from? Right. Let's try this one. The voltage ratio is 230 is to 12. The voltage ratio is 230 to 12. See that part flickering now? How do we change it to a ratio you can see? You always make the smallest one 1. You guys agree? So what I'm going to do, I'm going to make this 1. So I divide it by 12. It becomes 1. I divide by 12. I get 19. Isn't that basically what I just did there? I just tried to close the loop by saying to you, a ratio will say 230 is to 12. But we never give a ratio 230 to 12. A ratio is always given as something is to 1. Right, let's look at amps. You want to work out the secondary amps. How did I get my 2.11? If you take 0.11, the 0.11, and I multiply that with 19, do I get 2.11? I see the guys on the computers already did it. Well done, Graham. Right, well done. The guys are writing good answers down. So my question is, how do I do that? All what I'm going to show you, again, there's a formula, S equals VI, or I can use the ratio. There's choice, because we know what the one side is. So I'm going to show you a very easy way to do it. So I'm going to say to you, it's 25 divided by the voltage, and I get the answer of 2.11. So you can choose either this formula, where's my mouse? You can either use this, or you can use a ratio. Because now look, IS you want to know, they're inverse proportional, push that up. And what's IP? What's the IP? 0.11. Voltage primary side, 230. Secondary voltage, 12. And boom, same answer. The moral of the story is, which one of the two formulas will you use? I will always try to use S equals VI first, because you've got less transpositioning and issues to do, and you can go back to the old lovely formula sheet, and you can just imagine, if that was S, VI, I want to know what IS is P over V or S over V, and that's how you can work it out. But I already gave it the way to you guys earlier. I said to you guys, if you take that current and you multiply that with 19, isn't that the same current? Gentlemen, ladies, if you understand this three formulas, the three ways I just did, three-phase is about the same. That is the hardest ones. But with three-phase, I'm going to swear again. Have you heard about line voltage, line current, phase voltage, phase current? Just don't toss the two up. That's where the problem is. Anyway, are you happy with that? Right. Right, guys? Now, if you have a look, can you see the current ratio is 1:19? The voltage ratio is 19:1. How will I give it to the customer? 1:19 or 19:1?
19:1.
Thank you. Can I confirm? It's always based on voltage. Eh? Is that okay with you all? Ratio is always in voltage. One down or one up. This one is a step down transformer. Right. And the last one I'm going to do for tonight for transformers is just this one, because I want to do this now, prickle the brain, and then try again. Now this transformer, what do you guys think is the impedance of this transformer? I'll give you a hint. Look there. What percentage? Can you all see that? You all agree it's 3.8%. Now this is something you're going to learn if you have never learned it. Impedance means the voltage on the secondary side will drop by 3.8% when the transformer is drawing 278 amps. It's another name for voltage drop. Impedance. Or another name for the regulation of the transformer. So, if you take 415 and you take away 3.8%, you're going to get 398 volts. Well done, Graham. That tells me when this transformer is fully loaded, that voltage of 415 will drop by 3.8%. And guys, there's a formula for that, and it's actually on your nameplate, on the formula sheet. I'll prove it to you. Right, see that formula there? But there's one problem, and I must make this very clear. It says voltage no load minus voltage full load over voltage full load. When I was an apprentice, I've learned no load, full load over no load. In New Zealand, we can say either no load or full load. So Aspect said, to reduce the confusing, if they ever give you the voltage 415 and 398, and to get that 3.8%, just put in the voltages whatever you're given. So it'll be 415 minus 398 over 398. And then guess what? You will not get 3.8%, because to get 3.8, you must say 415 minus 398 over 415. And because of that, you will not get that in exams. They want to reduce the confusing. But if they do ask you what is the impedance, there it says impedance or volt drop or regulation. All what you do, you say 415 minus 398 over 398. And whatever answer you get, you put down on the exam paper. All right? But we'll practice this next week. Right. What's meant by the term MV rating? Right. Firstly, do you all agree this is a 200 kVA transformer? You all agree? See that? 200 kVA. Now, what does kVA stand for? Kilovolt amps. Right. Anyone with a calculator? Do the following. Say √3. Yes, maximum volt amps. That's right. So anyone who's got a calculator, go for me and say √3 times 415 times 278. What's a kVA? Is it 200? 1999, 1999? Yeah. So that's a secondary side. Secondary side, √3, three-phase, times voltage times current. Now try the primary side. What is √3 times 11,000 times 10.6? 11,000 √3 and 10.6. 19999. That tells me the kVA is 200. Now, if someone wants to borrow some copper and you go to the transformer and that person goes, cut through the copper and you create a dead short, what do you think is going to happen with that kVA? Is it true that that current will not be 278 now? It's going to go much higher, short circuit current. So what's happened with that kVA? It's going to go up as well. Now good guys, you see that formula? Your MVA rating, your fault level rating, is your kVA divided by the impedance. Right, and look at this formula sheet. There is your formula. Now all what it says V or S rating, S fault impedance. Now that formula, transpose it, it's the same as that. Now all I want to share, what is S? S is your 200,000. Can anybody tell me what's the impedance? How many percent? 3.8%, which is 0.038. There we are. This transformer has got an NVA rating of 5.26. So if there's a dead short, your kVA is going to go from 200 to 5.26 million. But only for how long? Look at my fingers. How many seconds? Because according to the legislation, the transformer must trip within 5 seconds. There goes the fuse. Now, while that little chappie is cutting that cable, is it true that this current will go up? That's what we want to work out. Prospective short circuit current. So it's I divided by the impedance. How many amps is given? 278. What's the impedance? How many percent? And there we are, 7,300 amps. So gentlemen, ladies, is that impedance important? You can work out the voltage drop, you can work out the short circuit current, and you can work out the new kVA under fault conditions. But you don't have to worry. Next week we'll spend about 20 minutes on this, and I'm going to give you some exercises to do as well. Now, just want to share, there's an alternative way how to do this. Now, could you remember I said to you that S equals √3 times V times I? If I was not given, can you say I equals S divided by √3V? It's just to transpose the formula. Now this is the same. So ignore the impedance, that impedance. So S divided by √3V. Isn't that S divided by √3V the same how to work out the amps of 278? And you multiply that with impedance. So the 200,000 volt amps, which is given, you got √315 and you put your acronym, and believe it or not, it's the same bloody answer. Now guys, that is transformers in a nutshell. There is one more calculation, but that is the three-phase one, which I want to board you next week. Any questions before we can have a quick 15-minute smoke break?